Okay, so the last section of Chapter 3, Section 11, is about organic compounds. So this is a term that we use a lot in pop culture. And organic, when you go to the grocery store, probably means that it was grown without pesticides. Whoops, whoa. Was grown, let's start over again, without pesticides or without hormones or without chemicals of any kind, right? What? Wait a second. I'm a chemist. I like chemicals. Okay, so that's what we mean in the grocery store. But when we're in chemistry class, we say organic. What we mean is carbon-containing compounds. All right, so we're going to round out our discussion of organic chemistry by talking about a special class of organic compounds called hydrocarbons. Very short section, so let's get to it. So first of all, organic chemistry. All right, so yeah, this is not what you see in the grocery store. This is organic chemistry. And we are talking about compounds that contain carbon, always, and always contain hydrogen. There are no organic compounds that we will care about that don't have hydrogen in it. And they usually contain oxygen, right? So C, H, and O, and sometimes contain nitrogen and sulfur and other things, okay? So C, X, H, Y, O, Z, all right? This would be a classic organic compound. Now, hydrocarbons, which is what Tro talks about here, they contain only hydro and carbon, right? Contain hydrogen and carbon. So you can see hydrocarbons. They contain only those two. The primary hydrocarbons are important because they're the primary components of fuels and other petroleum products. So looking at table 3.6, we get a list of hydrocarbons. These are some common hydrocarbons. The simplest hydrocarbon is CH4. Can you see how this only has a C and an H in it, right? CXHY. Well, in this case, X is only 1, Y is 4. But hydrocarbons all have that general formula. The structural formula of this hydrocarbon is C, H and 4 H's, right? Space filling model. The primary component of natural gas is what this stuff is. Methane. Propane. LP for gas grills and outdoor stoves. That's LP. Oh, by the way, what's the empirical formula? We don't have that list here, right? What's the empirical formula of methane? Pause the video and write that down. What is the empirical formula of methane? It's CH4, right? Because those are the lowest common number, or rather, I should say the reduced ratio, right? What's the empirical formula for propane? C3H, whoa, how do you spell H? C3H8. What's the empirical formula for butane? C2H5, right? What's the empirical formula for pentane? C5H12. Ethene. CH2, right? You see how I'm reducing those? And ethine is simply CH. Okay, so these are the structural formulas of all of those, and these are the space filling, give you a sense of some different shapes that we see. Okay, and so what do they use? Where are they? This is natural gas, LP, common fuel for lighters. You know, a lighter that looks like that. Right? Stick in your hand. Okay. This is N-pentane, a component of gasoline. Ethene, which is a ripening agent in fruit. And then finally acetylene, which is a fuel for welding torches. So these are some common hydrocarbons. Be a good thing for you to know. There's no questions that are given here at the end of Chapter 3, Section 11. And so my sense is that you should have a look at these structures, maybe write them down. If if you're thinking about something that you need to memorize from this, I think the most important thing might be that organic chemistry is the compounds. They always contain carbon and hydrogen. They usually contain oxygen also. And then the definition, I guess, of hydrogen, or rather hydrocarbons, which are compounds that contain only hydrogen and carbon. Okay, I hope you got a lot out of Chapter 3.